is more on the databases and designing applications or cloud solutions which are more data intensive applications, be it IoT, be it OLTP or OLAP kind of solutions.
Great, great. Yeah, thanks a lot. Thanks a lot for joining us today.
Thank you for inviting me, actually.
No, thank you. Nishan,
Yeah. Hello, it's me Nishan. I've been part with the Microsoft Tech community since long time, and since 2 years I've been taking a bit break from the community because of my busy schedules. I was one of the Microsoft MVP on Azure on 2018. Now because of the busy schedule, these days I've been just serving as myself as an IT consultant to Nepal government. I basically what I do is like I'm just concerned with the data of the Nepal government, and I just play with the Power BI and providing all the on-premise servers. So that's my expertise. And regarding the other Pradip, and we are working since long time, and that's great. Thank you.
thank you so much, Nissan, for your introductions. Yeah, thank you so much for joining. In fact, Nissan is part of this community, so it's not like I'm inviting Nissan, but it's us inviting you, Naginder, and other our special guests from Singapore, from Microsoft, from Marvin, Prabhath, who has joined us. Hopefully, Sajid Haran would also join us. I haven't seen him in the call so far. Yeah. So Sanjeev, yeah. So maybe next, Sanjeev.
Sure thing, Pradeep, and thank you very much for having me. Very kind of you. Really quickly, I consider myself as a user of Microsoft technology. I've been doing this for the past 25 years, but over the past 3 or 4 years, it's absolutely staggering actually what's possible with Microsoft technology, especially for kids who are in the perhaps the 15 to 20 years of age, the formative years. It's absolutely fabulous, what's possible. So my interest basically is in that space, to be honest, and technology-wise, everything under the sun with Microsoft, whatever, right? So long as it helps inspire people, create, be creative, that's the goal. And again, thank you very much for having me here. It's what a story, man! It's fantastic. All the very best to the team.
Thank you so much, Sanjeev.
Welcome, sir.
Sanjeev. Yeah. Next, maybe. Marvin.
Hi everyone. Thanks for inviting me, and congratulations to all the finalists. I'm Marvin. I'm from Singapore, and actually I'm from Sarawak, Borneo. If you know where is it. So myself is actually a developer. A software developer for web applications and desktop application, and I'm a Microsoft AI MVP, and specifically on cognitive service as well as so myself also experts in Angular technology, okay, and .NET applications. Yeah, so I'm more in Microsoft technologies like Azure, all the stacks for Azure and .NET, right? So myself also an entrepreneur lah. Yep. Thank you everyone. Thanks for inviting me.
Yeah, thank you so much, Marvin. Yeah. So next, Prabhath.
Hi all. Very good morning to you all. Thanks, Pradeep, for having me, and congratulations, and wish you all the best, or the finalist. I'm pretty sure we can bring the cup back again to Southeast Asia new markets. So my job role goes as partner technology strategies, working with partners across Southeast Asia new markets on building solutions on Microsoft platform and taking them to market. And also, I'm a social entrepreneur myself, running nonprofit outside of my day job. And yeah, I think I'm here today. I think Sajitharan and another few individuals from Microsoft is also joining. We can definitely bring right resources when needed to support you and guide you in this journey. Thank you.
Yeah. Thank you so much, Prabhath, for your support. Yeah, you have been really supportive in the previous days as well. Yeah, really appreciate it. Yeah. So let's move quickly to quickly to let's do alphabetic if I'm missing out anyone. Avinash. Yeah, let's not take much time, but yeah.
Hello everyone, my name is Avinash Gyawali. So by profession, I'm a game developer, and we were the Microsoft Imagine Cup Finalist 2020 for our project EDVR, and it's like a virtuality software. So right now, I'm currently working as a game developer for a company based in Norway. And yeah, I'm excited to hear your projects. Thank you.
Thank you, Avinash. So we'll leave the project team right now, and they would be the last person to introduce themselves and their projects. So next, Pradip Subedi.
Hello everyone, my name is Pradip Subedi, and I'm currently working as a program manager at CSAP Corner, which is tech community, and I was the world finalist in 2017 in Imagine Cup. Yeah, thank you and good luck to the newcomers.
I remember the picture that you took with Satya Nadella about 3 years before, maybe.
Yeah, I had a fantastic experience of that.
Yeah.
Great. Yeah.
Probably he's the luckiest.
Sorry.
Probably he's the luckiest one.
Yeah, he is, of course. I mean, having a picture with and headshot with Satya is not easy.
Yeah.
Yeah. So, anyways, yeah, thank you so much. And next, Sambhav.
Yeah. Hey everyone, I'm Sambhav Burtel. I'm a Microsoft Learn Student Ambassador in the Gold milestone. So I've been involved with the Microsoft community for more than 3.5 years now, and in this time I've been consistently delivering to the community in terms of workshops or other content. And yeah, I'm super excited about this. I'm someone who is really passionate about Azure, and looking at the projects the A1 and company have done. So I'm really excited to hear what they have to say.
Yeah, nice. Thank you, Sambhav. Yeah, so Sambhav is a strong pillar in the tech community in Nepal. So, and he's also, as I said, he's also a Gold Microsoft Student Learn Ambassador. Has been the MSLA for over 3 years or so now. So yeah, really good having join us today, Sambhav. Yeah. So with this, Utsav.
Hello. Hello, I'm Utsav. Currently I'm working as a game developer, and I was Asia finalist in 2020 Imagine Cup.
Great. Okay. Yeah. Thank you so much, Utsav, for your time for joining us today. Yeah. With this, let's head over to our project team, team virtual radiologists. So who is leading this team in terms of the project team? I mean, is it Avan who would start? But it's over to you, the project team. So basically the expectation is the team. What we want is give us a brief introductions about yourselves first, and then about your project. Do it this within like 15 minutes. Okay, don't take more than 15 minutes to introduce yourselves and your team. And then based on that, we want to note down our feedback for you, our suggestions for you, our recommendations for you, and we want to pass that to you one by one, or on a demand basis. Oh, I'm really sorry, Chandan, please.
I think I was missing one, so I raised my hand. So
thank
so
you so
quickly,
much
I
for
was
that.
just no problem. So yeah, I'm Chandan, and currently, like, I am involved as a DevOps engineer at one of the company located in the US. So currently working remotely, and beside that, we have been working on the same community since past 2 years, and we have been giving some awesome sessions and workshops with our Nepal Cloud professionals. And beside that, I was also the Microsoft student partner back in 2013, and And also, we were the national finalist for the Microsoft Imagine Cup 2014. Yeah, that's me.
Long
Yeah.
history, long legend, you know. Yeah. Yeah. Thanks a lot. And sorry, I mean, I didn't see.
It happens a lot. Actually, we don't have to worry about that.
But yeah, who doesn't know you? I mean, except for our guests from Microsoft and yeah, some of them. But yeah. So, anyways, thanks a lot. Thanks a lot, Chandan. In fact, like, yeah. So thank you. And moving forward, like as I was saying, please let's limit it to 15 minutes, and then to an Q&A for about 10 minutes or so, and then maybe then we would at the end we would also want to hear your 3-minute pitch as well, guys. Okay. Please do everything needed to help us understand your project so we can give our best to you. So over to you, team virtual radiologist. And by the way,
hello.
By the way, sorry. This
Yes.
we are recording this call so that you can also refer to the points that we put up forward here. Okay, so that was just a heads up. I should have given that in the beginning. Yeah, but yeah, over to you. Yeah, thanks.
Okay, thank you, Pradip. And I would once again like to say we are extremely sorry. We actually thought that coming into university we would it would be helpful, but unfortunately today there was electricity cut off at the entire university. So I'm once again sorry. I apologize for that. And now moving forward, we are team virtual radiologist from Nepal, and in our team, myself, Awan Shrestha, and we have here in the call Mr. Sanskrit Paudel, Ashish Adhikari, and Sabil Shrestha. And we have worked together in this project, and we are a group of computer engineering students. We are currently studying undergraduate. We are currently undergraduate computer engineering students, final year at Kathmandu University. And now, without further ado, I will just go into the project itself. So let me share my screen. Is my screen visible?
Owen, maybe a hi from all of the team members would be helpful as well. A quick hi.
Okay.
So hello everyone. So I am Ashish Adhikari from team virtual radiologist.
Hi. Yeah.
Hello everyone, I am Sabi Shrestha from Team Virtual Radiologist, and I'm studying computer engineering with my friends, and I'm a part of the team.
Great.
Hello everyone, I'm Sanskrit Paudel from the team. Thank you.
Great. Yeah, thank you.
Yeah. So just a quick note that Savil and I were working mostly for the software part, and Ashish and Sanskrit were mostly working for the hardware part in this project. Is my screen visible?
Yes.
So I will start with the presentation now. So our project is the PicoSat, and we have already talked about the members. So the inception of our project, how we started it as to tackle some of the problems, and one of the major problems the world is facing right now is the climate change, the global warming. There is industrialization and unmanaged industrialization, and the pollution, which is one of the major causes which is one of the major threat to the planet, to the earth. So in order to tackle all these kinds of problems, we thought that we should actually do something for the earth, and we came up with this project with our objectives to retrieve the real-time environmental parameters such as temperature, humidity, pressure, altitude, level of gas and dust, PM5 dust particle, and to detect a pollution level in the surrounding, to measure the weather of a specific area, be it a room or an open space, and to alert and help and cope with the climate change. We started this project, and there have been the project we have built. There have been many actually kind of things being done, but the difference is that the way the companies like Accurate, Tacon does it is that this kind of equipment are really huge, and they cost really a huge amount of money, and they are specifically for the research purposes in laboratories, in universities, etc. And in case of our own country, Nepal, there are in our country, we can see some of the boxes are placed in different kinds of cities, as you can see here. But when we go to the research and data analysis of that particular page of but we cannot get the actual data, and most of them are not in the working condition. So we started that project specifically for our country, so that anyone who wants to know what is the current situation of his surrounding, to know what is going on in his environment. So everyone living in this planet must have a right to know about the current status, current pollution level, current environmental status of his or her environment. So we built this project, and what our project before going on to this, I will just briefly talk what our project is. Our project consists of microcontroller sensors. It is basically a miniature version of a satellite which can capture, which can sense the data, and data is transferred to a ground station, and via that ground station, that data is transferred to a computer, and we have that data is stored in the database, and we show our data in the GUI. So we will come up with a demonstration later, but now let's go forward with the tools used. So we have used different kinds of tools here, different kinds of sensors to measure different kinds of environmental parameters, and we have used microcontrollers in our device. And for communications, for the data transfer, we are using 2.4 gigahertz ISM band with these devices, and our project is self-sustainable. It has solar charging panels, so it is self-sustainable. Similarly, we have used Azure for hosting the API and for hosting the web version, and we have used hardware Arduino. So data is currently stored in MongoDB, but we are planning it for Azure database. And for our server, we are using Node.js. For the desktop version, we are using Electron, and for the front end, we have used Chart.js and Design along with React. And the system architecture of our project is that first of all, there is this hardware system architecture. So our device consists of a microcontroller which have different kinds of sensors and power supply, and that device can be placed anywhere. Like we have also tried by dropping it from a drone, and we have tried it can be kept in a room, it can be kept in open space, and it collects all the environmental parameters and transfer them via ISM band 2.4 gigahertz. And currently our device have the range of 1100 meters. It can transfer, the device can transfer the data to the ground station up to the range of 1100 meter. And once that data comes to the ground station is a small box we will show in a demo, and it is connected to a computer. And once it comes down to the computer, then that data is stored in MongoDB database, and using the Azure web app, which of which the server is running in Node.js. This entire data is shown in graphs and charts, the live data as well as the past data of up to 24 hours. It is shown in the desktop app and the React web app version. So the feature of our project is the photo is here. It weighs around 100 gram, and its height is about 10 cm with a diameter of around 8 cm with a transmission range of 1100 meters. And building it in Nepal, it costs us around $19, including all these hardware resources. So the feature of our project is that it is portable, it has got wireless transmission, it is very economic to build, and since it has a solar power system, it is self-sustainable, and there's a GUI and there's the API as well, and it can be applicable in cities for monitoring the pollutions as a part of the sustainable development goals, and it can also be used in deep mining, where we can use it to measure the level of gases, because in deep mining the level of gases, we can hear sad news happening due to the level of gases. Similarly, it can be used as at your well digging. And the main motivation, the main factor that motivated us, that helped us to build this project was to do something for the goodness of our planet. And there are some of the limitations, which are the ISM frequency band might cause the interference within the signals, and there is also a battery put in along with the solar, and due to our budget constraints, we're not able to get a good battery. And if in case of we are like launching it as a satellite, or if you want to have data of like higher altitude, we will need some extra equipments to carry it down. And we are also working currently to incorporate or to use the different Azure services to use those services in our project. So about the future enhancements, we have thought of we have thought of some of the ideas, and some of those ideas are we have thought of like using it for brick kiln system. And another thing is uh, we have thought of using it as storing all those data and relating all this data to the data of the respiratory diseases. So how pollution causes respiratory diseases. So there's the data of respiratory diseases and there's our pollution data. And if we can bring some relation between those, then we can show that I will give an example here. So there's this satellite in our with me. So and it collects the environmental parameter of my temperature, and using the data of respiratory diseases data and the environmental data here, it can actually show like data like so things like what is the probability of occurring a respiratory disease to a person sitting here in that atmosphere, and we can go for it like that. Other than that, we can talk about we other than that we have also thought of that using a camera and data from there to predict the pollution. So yeah, it can also be used for data analysis. And we can also develop a mobile app out of it. And I think we will proceed with the demonstration now. And for a demonstration, we will start with the hardware part. So hardware part, I think Asis will give them.
So hello everyone. So let's move towards the hardware section. So basically what we have is we have
we can't hear you, Asis. Yeah. We just lost
can't
your.
hear you.
Yeah, we just lost your sound. I mean, we.
Can you just unplug your mic?
Okay, we will just swap it out here.
Okay.
Yeah, you can just swap it.
so sorry.
Yeah, that's fine.
Let me set me up. So am I audible now?
Yep.
Yeah, so what we have is we have a small portable device, so which is developed from combination of various stacks. So we can see that there are many stacks connected, and we have main microcontroller at the base stack, so that further enhancement or further sensors can be added at the uppermost stack. So what we did this is for so this can be used for various purposes. Just imagine that you are going to a sulfur mine, so you don't need a pollution sensor there. PM2.5 sensor really doesn't help you to monitor the harmful gases content, so this can reduce cost. So we can launch this device with the help of drone, or we can install it at our home or any place where we want to monitor the environment. So from this we have a NRFL radio transmission module, which sends data to our base station. So we have our base station here. So why we use this radio communication technique is that we cannot find GSM service or internet available in a tunnel system. Just imagine that you are using our devices at the mining criteria, or you are researching at the underground earth, where earth level, just like caves, and there we cannot find GSM service or any network criteria. So we used radio transmission system, or we can also use Azure IoT services, which after using the Azure IoT services, we do not need this ground station. We can simply send data from our device to the web services, and from where we can fetch our data back to the web platform. So this is how it really works. So for the UI section, I would like to call Avan back again. So,
so that is how the data is transferred to the ground station. And once the data comes to the ground station, let me share my screen again. So once the data comes to the ground station, the data is transferred to the MongoDB Atlas database for now using serial port library, and through that serial port library the data is transferred to the MongoDB Atlas, and we have a server running on Node.js server which is running on Azure, which creates an API, and through that API the data is finally shown in our GUI because at here currently we have not connected, so the data here is not accurate, not actual, because we have not set up the connection here. But if we set up the connection here, we can see that it shows the insert location which we have to manually put, and it shows the gas level, the pollution level, the current temperature of the in the satellite, the temperature range of past 24 hours, the humidity and the pressure range and gas range. It also shows the pressure and the humidity level. And for to check the reliability or accuracy of our data, we have used the Open Weathers Map public API. And if we compare for our comparison, we have here currently it is not working. I think the API is not working. So if we compare here the data from Open Weather Map API and our data is compared here, and it is shown in the chart. Similarly, the data can be also visible in the tabular form. The number of number of tables, the past data we want, temperature, humidity, pressure, atmosphere, it shows the data. Similarly, we can also see the live data, live temperature plot, live humidity plot, and live atmospheric plot, and live gas and live pollution plot. And similarly, we can see the history data of past 24 hours. There's no data showing because we have not put device on for last 24 hours. If you put, you can see the data here, the graph chart of how the data has been for the past 24 hours. And from here we can change the location of our satellite for the Open Weathers Map API here. And I think, yeah, that would sum up our project for now.
Thanks, Avan. Is this the end of your project? I mean, is there anything else that you want to mention before our mentors team they ask questions or provide suggestions to you?
I think this is about our project from our side. Anybody has anything to say from our team? Okay. Okay, this is it from our side, sir.
Okay. Yeah, thank you. So with this, if anyone would like to ask questions or provide feedback, recommendations, suggestions, yeah.
I'd want to ask a question here. So yeah, so you mentioned about Azure IoT here, right? So what are the other things, like apart from this receiving the data, what are the other things you might want to do with Azure in this project?
We are looking forward for ideas. If we can somehow incorporate the Azure, either some AI service or Azure Cognitive Service in our project, then that would really be great. We are brainstorming for the possibilities for that. We would love to incorporate any of the Azure Cognitive Services into it.
Awesome.
Hey guys, I have few questions. Can I ask now, or do we have some kind of turns as in one? I mean, how do we go about asking the question? Can you just?
Yeah. We can ask questions, Raginder. Yeah. The floor is open for you. Yeah.
Yeah. So I have a lot of questions actually. So please bear with me. Okay. First, what is the messaging protocol? Are you using MQTT, or what protocol are you using for this? Avan or maybe Abhishek, can you tell me what protocol are you using? Is it a MQTT based messaging protocol, or is it simple HTTP messages?
Oh, we are using HTTP messages for that.
Sorry?
HTTP.
Okay, okay. And what about cloud to device messaging? Is there two-way communication, or is it just one way that you send the data? That's it.
It is just a one-way communication. We have our API, so that's
so is there any future enhancement that you're thinking of where you could? Is there any future enhancement that you're thinking of where you could make this a bi-directional communication so that maybe sometimes you have to reset the device or restart a device from remote location? You could do that. Are there any such enhancement planned?
Yes, actually, we have enhancement plans to make the data transfer bi-directional. For example, if we could just control the hardware part from our own laptop, our own device, it would really be great. And also similarly, like as you just mentioned, turning off some of the features. Like Ashish have already mentioned that it is built on stack, so not every time every sensor might be necessary. So if we could just turn off like one of the sensors, one of the reading parameters using the device from our side, it would really be great using the bidirectional communications.
Got it. And from the connectivity part, right? I really like the idea of putting a remote box or a remote gateway, and then all your stations connect to that particular remote station, and from there the data is passed on. That idea I really like because not every location will have internet, not every location will have GSM services. What is the range that you said? It is 300 meters, right?
The range is 1100 meters.
1100 meters. So yeah, that pretty much covers a lot of things. So my next question would be, have you thought about making it open source or the platform? So my I won't say advice, but what I want to see this as a platform which can be used worldwide, right? So for example, anybody in India wants to send you data, they could just buy this sensors, put it in my location, and you give me some endpoint where I can stream my data and I can kind of config either on the device or on the remote station or wherever I can do that. If we can make this open source, I would like to see data coming from a lot of locations. Then you can do some analysis on top of it, and then this could be kind of a world-based station or something like that. Have you thought of that, or what are the plans on that?
When I was talking about enhancements earlier, our one of the ideas was quite similar to this one. So what we would have is, since this device is quite a bit cheaper, we have built in cheaper price, so we can build it in cheaper price. And what can happen is that many people across now, like for currently, let's say Nepal and India, many people across let's say worldwide, many people across the worldwide can put this device in their homes. And what we can do is we can have a portal where actually we can show the data. So the data would be going in two ways. First of all, whoever is installing, can see the data in his or her portal, and another way it will be coming for us for the analysis part. And not only the person can see the environmental parameters of his or her own, the person let us create like a social media related to environment. So what a person can see is the person can see that in my home the pollution level is this, and the person can follow his or her friend and see that in his or her home the pollution level is that, like my home is a little bit more polluted than his or her home. So actually that was one of the idea that we came up while brainstorming a few days earlier. So yeah, we can actually move for.
I think what would be also wonderful is to add more sensors to it, and things like soil moisture sensor. This could even be dropped into an ocean, and you can measure the pollution of an ocean or a sea, something like that, right? Do you have any plans on that as well? Are you trying to incorporate more sensors into this going forward?
Actually, we were planning for one photo one. I think Ashish or Sabil will talk about it. Sabil, Ashish.
So
We lost his sound.
Avan, if you can keep yourself out of mute, I think then we can hear him.
Ashish, we can't hear you.
Avan, if you can unmute you. Yeah.
So am I audible now?
Yes, yes.
Yeah.
So what our concept is, so the main concept of the stack development is that so we can add as many sensor as for the progress. So if you want to now, so we have limited sensors here, only 5 to 10. So if you want to just say that you just said that you want to measure the pollution of the ocean, like, so we can add we can remove this dot sensor here. You can see it is on the toppermost stack. So we can simply remove this stack and add another stack that can really measure the pollution of the ocean. So the main concept of the stack was to make it as reasonable and as available for every purpose. So that was
okay. And I think there are two more questions. I'm sorry. One is more about the, as I said, the cloud to device thing, right? So maybe some kind of over-the-air updates that you want to send for the software and all that. Please think about that as well. How you would tackle that kind of thing in the future. Let's say somebody adds more sensor, you want to update the software. How would you do that? So maybe some kind of over-the-air updates capability you would want to add to this. And the second suggestion would be since you're just collecting the data right now, right? And analysis is the second part of it, where you have somebody else do the analysis. You also asked about incorporating cognitive services to kind of make it more proactive rather than reactive. I'm not sure if you've heard about anomaly detection API in cognitive service. I feel that could be a very good addition to this. What it can do is essentially it can track your data, and whenever data is out of certain bounds that it thinks it's an anomaly, it can raise a message, right? So that can be used for either inferencing at the cloud, or you can even deploy an anomaly detection container on your device if the containers are supported, right? You can deploy a Docker there, and then you can essentially route your message from that Docker and then to the container to the cloud. And then that Docker could essentially inference the data real time and then tell you about any anomaly or something like that, right? So that could be a useful addition that I can think of. And again, as I said, the other thing, I could see this as a platform for the world to send their weather data, right? Not just for Nepal, but what if we can make this open source and have people just take that software that you have, buy that hardware, put the software there, and off you go. Something of that sort. If you can make this, will definitely be very interesting. And I mean, you have my email address. I would definitely want to be in touch with this. I think that we can go a lot of places with this. Thanks. And this is quite interesting. Thank you.
Sure, sir. Thanks a lot, sir.
Yeah, Nagendra, I would suggest maybe you could share your details in the chat, so it would be easier for others to connect as well if needed.
Okay.
Apart from the project team.
I don't think the chat is enabled for this, but you have my email address, right? Maybe drop an email there, or I can drop an email and or maybe create a Teams group in Microsoft Teams. You have my email address, right? Let's chat over there. I think there is a lot of things that we can do on this.
Yeah,
that will be good.
That will be good. Yeah, sure.
Thank you, guys.
Pradeep, this is Sanjeev. I'm terribly sorry to jump in here. I've been beckoned by the family, so I'll have to leave shortly. But just thank you, Nagendra, for those comments. Spot on. Really quickly, folk. Couple things. First of all, fantastic job. This is amazing what you folks have actually been able to do. on three sides, right? The solution angle, the hardware, and the software. This is absolutely fantastic. From a practical standpoint, when you take this to the market, right? And I used to work for a subsidiary of Toyota for about 10 years, so I have actually put cars into market. One of the first things you actually think about is calibration, right? So if you have your temperature sensor just sitting at your home, right, and you have a physical thermometer next to you, something that is reliable, if you measure the sensor, the temperature coming out of the sensor and the actual temperature over a period of a month, there will be a difference in measurement. Okay, so the first thing you actually do with any kind of sensor is what is called as calibration. You use, let us say, ice. You have a physical, thermometer that'll give you, like, let's say -32, something like that. Actual temperature. You take the sensor output and see how far out it is. You take boiling water. You take the actual temperature with the thermometer, like a DS 1820B or something like that, and see that, and then do the calibration, right? So that's the first step. The second step is how do you maintain it over a period of time? And that's where what Nagendra was talking about, like the cloud to device communication comes in to say, hey, what is my creep over a period of time, right? How is my temperature actually like varying from the real output, right? From a physical thermometer, and how do you keep that calibration? So that's what we look at in the real world, right? That's one thing. The other thing is when you're looking at all this electronics, you have to be cognizant of noise. Okay, because usually, and this in some cases, what will happen is you'll have external noise, right? I mean, you have like aeroplanes flying, things like that. They will interfere with your sensors, and the output that you get will have what is called as ringing. Okay, so you think of a wave, okay, like a wave in the ocean. It is very calm, right? Let us say. Then let us say a boat goes by it, the wave gets disturbed, and you have like small waves on top of the big wave, right? That small wave will disturb your signal essentially, right? So that whole area is called as digital signal processing, where you have to do what is called as dispersion correction to take out that ringing and then get the real signal so that your signal is actually clean and then understandable, and then you can take action on it, okay? So one recommendation is within Microsoft Excel, as an example, you can take your output and you can do a fast Fourier transform. Okay, when you do a fast Fourier transform, it actually is going to break out the frequencies and give you what is noise and what is real signal, right? Those kind of monitoring technologies, they're, how do you see, you get into a little bit, walk into a little bit of applied mathematics and things like that, but that's the excitement, okay? It is not just pure software and cloud and cobbling up things together. How do you actually make it real by combining the real world, like, noise, taking out the noise, doing calibration on the fly, all these things. It is hard for you to actually like get into some of this right now, but in your, slide, you have the one slide where you say, hey, what else can we do, or, improvements and enhancements. Kindly consider that, right? One last thing. When you put modules out in the market, you have to think about environmental factors. What do I mean by that? When you put it in the Himalayas, one of the things that may happen is water, humidity getting into your modules, right? Electrical, your PC board as an example. When you have a high temperature and then your water in that module, between your soldering joints, you will have what is called as ion migration, and they can ruin your module, okay? So packaging that well is another thing. So calibration, noise correction, packaging, these are three things that you want to indicate if you want to take this into real world, right? Into the market, right? Kindly make those as like line items in your presentation at the very end and say, if we want to commercialize this, these are the considerations that we want to take in, okay? But with that, I will let you be. Outstanding job, okay? Outstanding job. Like Nagendra said, kindly include me as well. I do things for folks like you. If you want to get into graduate study in the US, if any of you want to get in, kindly let me know. I did my graduate studies in the US. If you want connections with professors and things like that, all that good stuff beyond your project, kindly let me know, okay? And I think Pradeep has my connection. Would be very happy to help you out with all that other good stuff. Okay, with that, congratulations and all the very best with your finals. Okay, take care.
Thank you so much, sir.
Yeah.
Thank you, sir.
Yeah, thank you so much, Sanjeev. Yeah, for your comments and suggestions, recommendations, and all the offerings, all the Yeah, thank you so much. So we would like to, because we have so limited time, we want to give this space to our guests. I think Naginder has already provided his suggestions. Sanjeev has done. Maybe is there? I mean, Prabhath, if you would like to speak, Marvin, if you would like to speak. I mean, we would like to give space for you guys.
Yeah,
Because
Pradeep,
all of us are
maybe
most of all of us are from Kathmandu, so we can easily connect with these guys in here whenever needed as well. Yeah.
Yeah, Pradeep, maybe I have a few words for the team. So first of all, I think it's a really fantastic project and a very interesting, and very impressed by what you guys have done with the hardware itself and the project itself. So I think it's pretty good, and the dashboard also looks very nice. And probably I have a few questions for you guys. First of all, is who is your target audience again? Is it the public's household individuals audience?
Yes, the household individuals.
Okay, so it's good. I think it's so as I think Naginda and Sanju actually suggested. So first of all, we have to think of how we can deploy and update so the devices and what is the software running on it, and yeah, so that would be the very crucial parts, because along the way we want to fix the bugs, we want to actually introduce more features, and we want to introduce more I mean, some of the things that we want to actually deploy to the devices. So that will be one of the crucial things that we must always think of. And I think I'm very impressed by what you guys have actually done with the radio wave technology. So it's true. I think some of the rural areas, remote area couldn't have the stable internet connectivities, or sometimes don't even have. So radio wave technology really helps that. And I think what we can think of is leveraging Azure technologies like IoT Hub, IoT edges, all this. Probably you can think of like deploying the software to the hub device that you have on. Just how you mentioned about that, to communicate as an intermediate device for that. So through that, probably the software can be deployed through the radio wave to the devices. But of course, radio wave will be slower, and we have to keep the packages light. So that will be very important things to think of. And second thing, I would say probably we can market it as a disasters prevention devices. Okay, so since you have a smoke device or the air quality sensor deployed on the IoT device, as well as the temperature sensors, so I guess probably you can think we can market it as disasters, whether it's natural or human kind of disaster, like the fire outbreak. So probably we can use it together with the Azure Connected Service, like what Naginda has suggested, the anomaly detections. So over there we can see whether there's some disaster happen at the area or even a household. So other than that, probably we can put in some earthquake sensor as well. So that will probably be helpful for some of people to prevent natural disaster. And to market it as one of these kind of device, then probably you can sell it off to some of the command center of the governments or the authorities or the local authorities. Then probably from there you can extend the connections to more people, and you get the funding for this, and you can build a more sustainable projects. Right. So I think overall it's really good. I see the potentials there, and if you need my help, just connect me. I think Pradi, you can help to extend the email contact to them.
Yeah.
They need some help.
Sure.
Right.
Sure.
So,
I'll do that.
Yeah, that's it from myself.
Thank you, sir.
Yeah.
Thank you so much, sir.
Hi, Prabhath here. I think overall project is awesome. I think you have picked a niche area where you can show real value, and also you have identified your own local area challenges and how to provide the solution there. And I'm sorry, I don't know whether I missed this part because I had to take a urgent phone call in the middle when you were presenting the solution. Did you mention about the business plan and go-to-market strategy as well on your slide deck, or have you already planned it?
No, actually, that was not in the slide deck. But for while submitting our project for the Imagine Cup itself, we actually needed to prepare kind of a plan, not a plan, but a kind of a business model there. So I just let me open it. So what we have in our as a business plan that we submitted to Imagine Cup as an initial part is as an initial part of the submission is that our target audiences are mostly households, so people who want to general people who are curious about their health, and also the mining industry and the industrialists who want to monitor environment in their industries and factories, and also the smart city planners for whom it is necessary to monitor the environment. And yeah, that is what we have. So we had done for now.
All right, Avan. I think one thing I can do, because we have specialized people in our subsidiary on go-to-market. I can maybe set up a quick call, maybe 30 minutes call even tomorrow, based on the availability to really look at the business plan. I think that will also add additional value to your solution, because I don't want to really focus on technical, because we have experts like Nagindra and Marvin and team. So I don't really want to focus on that area. Maybe if you think you need some support on the go-to-market strategy and the business plan, I'm more happy to bring a resource and support you there.
Sure.
Yeah, that is great. That is great, Prabhath. Yeah, I think that team can connect with you on this.
Yeah, we'll do that.
I have a really okay. Yeah, Prabhath, you could continue.
No, sorry, please go ahead.
Yeah. Okay, so I just have a small suggestion once again, like listening to the suggestions from all the other experts as well. So my suggestion would be to kind of modularize the hardware part as well. So since we have our stack, we have a controller, we have a base, and we have our stack there. So we could modularize it in such a way that anybody who wants a specific type of data could get it. So we could add something like sound sensors, and we could add, just like Marvin said, sensors for earthquakes. So everybody, the user base could be increased from a few thousand people in an area to probably 1 lakh people in an area. So that is something that could be done, and also it could be done in such a way that connecting and disconnecting could just be made as easy as connecting a switch to a socket board. So if the hardware making can be like changed into something like that, can be upgraded into something like that, that would be probably amazing for this project.
Yes, thank you so much. That good idea.
Pradeep, do you want to speak a bit about how you find their project? What do you think about it? Like, because I've been to the US, participating in the Imagine Cup. What perspective do you want to, send, provide them? Like,
yeah, okay. Thank you, sir, for the opportunity to speak. The idea is really great, fantastic, and the former or past speaker already talk about the technical perspective, and I was thinking about the business perspective as well, because the jury member might ask or will be asking more about business perspective as well. So I think they have to be clear about their business model, and then the target market, and also about if there is similar product in market or not. If so, how they are going to compete with them. And that is yeah, what lack in their slide or PowerPoint or presentation is that business perspective. So I suggest them, or I want to recommend them to add something related to business and how they are going to kill it in the market, how they are going to sell it, because all the effort and all their hard work is gonna pay only after they go to market, right? So yeah, that is what I want to suggest.
This is a great suggestion, Pradeep. Yeah, because I think what you really need to add is the business analysis, the competitor side of the things. In terms of how you are unique, how you are distinct from near competitions. How you can really be differential to others. So I think that's a really good feedback. I think please do not miss this in your PPT
sure,
or your success.
Sure. Thank you so much, sir.
So any last comments from anyone? Because we are out of the schedule already. But yeah, all of us can connect with them. So the project team can connect to all of us. I mean, it can be both ways. Any last feedback, or the team? Do you have any last questions before we close today?
Any questions?
So yes, I would like to add some few words and add some comments. So yes, very good project. It was, really amazing to see your projects. So what I would say is, like, I would urge you to focus on the presentation along with the technological enhancement, right? Because you have made an awesome project, but like when you try to present it, it has to be also, amazing. So I think you have to focus on the presentation aspect also. And then you can also talk more about, like, your project is purely about democratizing data collection. So please talk more about that, and talk more about the accessibility, and talk more about the cost effectiveness, because I think these things are the pillars of your project. So emphasis more on that. And then yes, also emphasize more on the Microsoft tools than other tools you have used, because that is one of the judging criteria in the Microsoft Imagine Cup. And yes, so yeah. So if you want any help regarding the presentations and the judging criteria that you have to focus on, yeah, please, I'll send my details, and then I can we'll love to help you out.
So,
perfect.
Thank you so much, sir.
Yeah, perfect, Avinash. Yeah, thanks a lot. I mean, you're because you have fresh memories from Imagine Cup from last year. So yeah, this really helped. And plus, you are also into the hardware, electronics and the game development and things like that. So yeah, perfect. Awan, I mean, he's local to Kathmandu, so you guys can easily connect with him as well in the. So yeah, I think.
I've got one question here.
Yeah.
So currently, what we in the process of submitting for the initial part, what we submitted was we submitted the GUI part, which I showed, the React built web application, and we also submitted desktop app version, which was built using Electron.js. So while proceeding for the finals, would it be good idea to pick just one, either web or either just desktop, or should we just expand it more, like there is web, there is desktop, and can we also like try for an app as well, mobile app as well? So what would be your suggestions on that?
No, you could only show one demo, but you can mention that we are doing cross platforms. Our software is like cross platform. Just mention that, but only show the demo in one, because that's the same thing, like across every platform. Just show the demo in one and just mention that your software is cross platform. That would be
Okay, thank you, sir.
Yeah.
All right. So are we good to close the session then?
Yes.
Yeah, just a quick question, sir.
Yeah.
One question. So, like, how many teams would you be competing with?
In our art category, there are six teams.
6 teams. for the global championship or what?
For the art category, we have 6 teams, and out of 6 teams, three would be selected for round 2, and the winner will be for the final the round.
Oh, okay. So right now you're going to it's a remote competition.
Yep.
Oh, and then you'll be like flown to somewhere after that, is getting selected
No,
from.
no, it's actually all virtual, starting from March 25th to end of the March.
Oh, okay.
Yeah, this year it went all virtual.
Yeah.
There are like total of 37 teams. Is it 37 to 40 teams worldwide finalist?
Yeah, something like that.
Yeah. So let's call them as top 40 teams from the world.
Oh, nice. That was same with us too.
Yeah. All right. So all right, are we good to close now?
Yeah.
Yeah, before we close, okay, so like we have a whole list of the mentors here, really good mentors, really good suggestions today, and they really would like to also connect as well. And you guys can, as a team participating in the Imagine Cup, please do reach out to them as per your requirements, like, you know. Yeah, so with this, all right, with this, thank you so much everyone for joining in. Thanks to you, Naginder, for your support. Prabhath, Marvin, Sanjeev, Chandan, Pradip Subedi, Avinash, Utsav, Nissan, Sambhav. Did I miss anyone apart from the project team?
You missed yourself.
No, I said, oh yeah. Nice. Yeah, thanks a lot. Thanks a lot, everyone, for your active participation today, for your active support. We have recorded this session, so we would also post this somewhere, maybe in one of our YouTube channels, and maybe you know, you could refer to them, particularly the team, the project team, and then yeah, and let's connect, okay? And I would forward you the details. Whoever needs whoever's details, I can be the point of contact for that. And let's do a great job, and good luck, guys. I mean, you're doing good. You're doing great. Let's do it really good, and let's bring this cup to Nepal. Yeah. With this, yeah, thank you so much. Thank you so much, everyone. Have a good day. Yeah. Bye-bye.
Bye-bye.
Thank you so much, everyone.
See you all.
Thank you, sir.
Bye.
Bye-bye.
Bye.